Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the 2025 physics examination. We will focus on questions related to light as a wave. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. We are looking at a classic double-slit experiment. Here, our green light is split into two separate wavefronts as it passes through the slits. As these waves overlap, they interfere, creating a striking pattern of bright constructive bands and dark destructive ones. The spacing between those bright fringes, delta x, depends on two main things. It grows with the distance to the screen, L, but shrinks as the slits, D, get further apart. To find our answer, we just rearrange the formula, plug in our values, and calculate the slit separation, making sure to round our final result to 3 significant figures. The official feedback highlights a classic trap in VCE physics, the hidden logical step. Even if something seems obvious from Part A, the examiners want to see the complete chain of reasoning for Part B. Here is a breakdown of how to frame this for students, incorporating the official feedback into that same Option 2 narrative style. The why behind the change, 2-mark logic. When a question asks you to explain the effect, think of it as a domino effect. If you skip a domino, you lose a mark. Step 1, the frequency wavelength link. First, we address the light source itself. Because all light travels at the same speed, frequency and wavelength, lambda, have an inverse relationship. The logic, lowering the frequency means the light has a longer wavelength. This is the missing link many students forget to state. Step 2, the pattern response. Now, we look back at our formula. The logic, since the fringe spacing is directly proportional to the wavelength, lambda, increasing the wavelength will cause the bright bands on the screen to spread out further. Warning sign # common pitfalls from the examiners. Don't assume they remember Part A. Even if you just used the formula in the previous section, you must explicitly state it again, or describe the relationship here. Every sub-question is often marked as a fresh start. Interference versus diffraction, this is a big one. Interference is about how the two waves from the two slits overlap to create bands. Diffraction is how a single wave spreads out as it passes through a single opening. In this question, we are talking about the spacing of the interference bands, so stick to the double-slit interference logic. Don't start talking about $W, slit width, when you should be talking about D, slit separation. Sample full mark answer. A lower frequency results in a longer wavelength. According to the relationship, the fringe spacing is directly proportional to the wavelength. Therefore, the bright bands in the interference pattern will become further apart. Show every logical step. Each sub-question is marked as a fresh start, restate formulas and relationships even if used in the previous part. Think of explain questions as a domino chain, skipping one link loses a mark. Don't confuse interference and diffraction. Interference, two waves from two slits overlap to create bright or dark bands, uses slit separation D. Diffraction, a single wave spreads out through a single opening, uses slit width W. State the frequency wavelength link. When frequency changes, explicitly state, lower frequency longer wavelength, via C equals F. This is the missing link many students skip. Examiners want the full reasoning chain. Watch your rounding and units. Convert all values to SI units before substituting NMM, MMM. Round final answers to 3 significant figures unless otherwise specified. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.